Today I'd like to talk about one of the environmental concerns that has been raising alarms for us. Pope Francis has talked about it a lot in Laudato Si and subsequent teachings. Certainly it has been a topic of wide interest for people throughout the world, and that is that the whole concept of global warming, climate change, and what we can do to stop it. One of the interesting propositions that's put forward is removing the carbon dioxide that's in the air. So if we can do that, we can purify the air, we can make our atmosphere a lot better, we can slow down the global warming. And in Iceland, they have, and other areas, they've been working on this by attaching fans to mental structures to scrub the atmosphere by sucking carbon dioxide from the air and then storing it underground. It's called direct air capture. The one in Iceland is referred to as Orca. It is the largest such facility in the world. It captures about 4,000 metric tons of carbon dioxide per year. Now you might say that seems like a lot, 4,000 metric tons. About how many tons do we need by mid-century to really control the amount of carbon dioxide in the air? And the answer to that, scientists project as 10 billion tons. So you can see from 4,000 to 10 billion, quite a leap. So we would need a worldwide enterprise that is twice as big as the present oil and gas industry, and that works in reverse. Oil and gas is extracting and polluting. What we have to do is the opposite. We have to take it out of the air and then put it back into the ground. United Nations Intergovernmental Panel on Climate Change talks about the need we have for negative emissions. So this would be along that line. Various companies are involved with this project. Climeworks built the Orca plant, and then Carbon Engineering, they have a different kind of direct air capture plant, and that is in British Columbia. So we have Iceland, we have British Columbia working on this. At Orca, the fans suck the air into a big black collection boxes where the carbon dioxide accumulates on a filter. Then it is heated with geothermal energy and is combined with water and pumped deep underground into basalt rock formations. Within a few years, the carbon dioxide turns into stone. So you can see the positives in this type of approach. It takes energy, though, of course, to run the plants. 10 tons of carbon dioxide are emitted for every 100 tons that are removed from the air. So there is that trade-off there, but certainly it's a positive one. Carbon engineering plants can run on renewable energy or on natural gas. So again, that would be another way to make them even more energy efficient. When natural gas is used, the carbon dioxide generated during combustion is captured. So that, again, not released into the atmosphere. Carbon dioxide can also be injected into geological reservoirs, such as depleted oil and gas fields. Carbon engineering is taking that approach in partnership with Occidental Petroleum to build what is expected to be the world's largest direct air capture facility in southwest Permian Basin, which is the most productive U.S. oil field. So they're looking at this and saying, well, this is a possible way to go to really reduce our carbon footprint, to make a deep impact in terms of the environment and to reduce global warming. Direct air capture plants globally remove about 9,000 tons of carbon dioxide from the air annually, according to the International Energy Agency. So there is a movement in this direction. If it gains momentum, of course, it could really be significant. Now, people ask, well, what is the cost presently to do that? The cost is presently $500 to $600 per ton, and within a decade, it could fall to $200 a ton or lower as more of these plants are being built and as they become more energy efficient, according to Colin McCormick, who is the Chief Innovation Officer at Carbon Direct. Companies bought carbon offsets, and the carbon offsets, of course, are ways of making up for the pollution that they would create. The most popular projects for these carbon offsets presently are reforestation projects, but many offsets do not deliver the promised environmental benefits. Well, certainly direct air capture seems to deliver them. So as it becomes more sophisticated, as it becomes more energy efficient, certainly it's something that a lot of companies will explore for the carbon offset. And the leading companies that are involved with this so far are Microsoft, Stripe, and Shopify. So this is a potential movement, and it's certainly something in line with what our Pope Francis, has been speaking about, that we have to use science in a very positive way to make a good impact in terms of the environment. We have to do this for the future generations. We have to think about those who will come after us. We have to think about being responsible in terms certainly of reducing our pollution, but also reversing now some of the effects that are already out in the atmosphere. What can we do to get to these negative emissions to reduce what we have done? So direct air capture is possibly one way to explore. And it's good to realize that there are scientists who are working on this and moving us in a positive direction so that we can become even better stewards of our environment.